Hello everyone. Today we'll be looking at this problem called course schedule. So this is from cses graph algorithm section. So the problem says that you have n courses and there are m requirements. So what does a requirement mean? A requirement has two courses A and B, and a requirement means that you need to complete course A and then move on to B. So you can't really complete A after B. Right? So let's say if I have 1, 2 as a requirement, so I need to complete course 1 first and then only I can do course 2. For that I'm not allowed, right? So the question is that my task is to find an order in which you can complete the courses. So like we can just look at a test case to take an example. So let's take this test case as an example where we have these three restrictions. One is 1, 2, the other one is 3, 1, and the other one is 4, 5. So this means I can complete course 2 only after course 1, course 1 only after course 3, and course 4, uh, and course 5 only after course 4. Right? So then you can very well understand. So let's say I do it in this order that I complete course 4 first, then 5, then 3, then 1, and then 2. So I guess you can understand that all of the conditions are valid because 5 is completed after 4, 3 after 1, and also sorry 1 after 3 and 2 after 1. Uh, Now it's not necessary that this is the only order of doing it, right? We could also do it this way that complete 3 first, then 4, then 5, then 1. Also, we could do it this way that we could complete 3 first, 1 then 2, then 4, then 5. Okay? So there are different such orderings which are valid, and my task is to find one of those orders, right? So if you can relate it a bit with graph algorithms, so maybe till now you have understood that we have to apply topological sorting. So for those who don't know what's topological sorting, so topological sorting has this condition that let's say in a graph, if I have an edge from node u to u, right? So then in the topological sorting, in that ordering of elements, I should definitely have u first and then v, right? So v should not appear before u in any case in any condition, right? So that's how we need to do it. So you can very well understand here also you have the same condition. If you have realized and if you could map it, so we have the same condition. If we have 1, 2, then course 1 should not be done before 2, right? First 1 has to be done and then 2. So the same happens with topo sort, right? That if I have an edge from node 1 to node 2, okay, so node 1 has to come first and then only 2. So can you understand that I can actually map these requirements to edges in a graph, and they have to be directed because 1, 2, right? It is not 2, 1. Both are different things. 2, 1 means I'll do course 2 first and then 1. But 1, 2 specifically means that I'll do 1 first and then 2, which means the edges are directed. So it's a directed graph, right? Okay. Now the question says something else, that if there are no solutions, you have to print impossible. So when let's look a bit at this case, that when is it impossible? So you know, I believe you know that we can apply to in only directed acyclic graphs, right? So directed to is I think quite clear as all the edges here are directed, but can I apply those on acyclic on cyclic graphs, right? On acyclic graphs. So if a graph is let's say cyclic, let's just take an example. Let's say node 1 is here and node 2 is somewhat here and 3 is here, right? So if this graph is cyclic, let's consider that there's a edge between 1 to 3. There's an edge from 3 to 2, from 3 to 2, and also there's an edge from 2 to 1. So can you understand? It is like it is something like this, that 3 should come only after 1. So let's say I place here 1 and then I place 3 here, right? Then the condition says that 2 should only come after 3. So let's say I put 2 here, but then this 2 1 edges is what causes the problem, because if the first two conditions are true, the third condition becoming true is impossible, because I need 1 after 2, which is something that I can't do, because if I put 1 after 2, the other two conditions will be messed up, right? Because this one is still okay, but this condition is no more being predicted if I put one after two, right? So that means problem is that if I make a graph cyclic, I would be able to find no such ordering of edges. So that is when we will return impossible, right? That we are not able to find an order in which I can complete the courses provided these requirements, right? Okay, so one thing that's very clear is that it's a graph question. So as it's a graph question, let me just take the inputs. So it's like uh, int n and m, fin n and m. Okay. So once this is done, I will just build a graph. So vector or vector, okay, graph of n plus one. Right. So I have n edges. So I'm just building a graph of n plus one. Right. Okay. So then anybody who has studied toposort knows that the first thing that we do in toposort is we just figure out the in degree of all the edges that we have. So just to explain what in degree is, so in degree is nothing but the number of edges that is coming towards that node, right? So can you tell something that if a node has in degree 0, what does that mean? So node having in degree 0 means there's no edge that coming towards that node. All edges are going out of that node. So that means if let's say all edges are going out of a particular node, so I can do that course first and then I'll have to do all the other courses. Can you understand this? That if any node has in degree 0, that means I have to do that node first and then the others. Right? So I'll just make a in degree vector to figure out the in degree of all the nodes that I have. And let me first set the values of the degree of all nodes to be 0, right? Okay, and then I'll try to just formulate this graph. So for int I go to 0, I less than m, I plus plus, then she has defined two integers, take inputs and what's up taken inputs. Okay, see, so this is a directed graph, so I'll just do graph of x dot push back y. Okay, and one more thing. So can you tell that when I have a edge from x to y, in degree of y is increasing, right? So in degree of y will be plus plus. Okay. So now what was our idea? So now we'll simply use BFS to figure out. So from this video you can also learn what toposort is. Right. So let's just see. Now I'm just writing the code for toposort, nothing else. Right. So I'll simply use a queue as in BFS we generally use a queue. And first of all what I'll do is all nodes that have in degree 0, I'll go from 1 to n, and all the nodes that have in degree 0, if in degree of I is equal to 0, then I push all such nodes into the queue at first. And once I've done that, what else do I need to do? Once I have done this, what I need to do is I simply need to run a simple BFS code, right? Okay. So tell you one thing. I will also need to store the order, right? So for that, let me just make a vector in topo where I'll be just storing the elements, right? And while queue is not empty, I'll simply take the first element that's there in queue, then I'll just pop it, and I will see all the neighboring elements that are there in queue. So for auto ID graph of queue, okay. So see now what I generally do is I am taking all the neighbors of u, right? So if I'm taking all the neighbors, I also once I pop it, I will have to push it into my topo, which is storing all of that. So I've pushed you. Okay. So now the point is, now see, if there exists an edge from 1 to 2, right? And let's say 1 is the element that is in degree 0. right? So and there exists the edge from 1 to 2. So what do I need to do? I now see, can I put 2 just after 1? How do I figure that out? I figured that out by seeing that is this the only edge to 2 or there are other edges that are going towards 2. So the point is that if like I'll just do a degree of it minus minus, and if after doing this, if remove, so see, if I'm doing integrate minus minus, what am I doing? I'm actually removing that edge, nothing else. This is a directed edge, right? So if I'm decreasing the degree of a particular node, I'm basically removing that edge, right? So and after that removal, if my degree of it is equal to 0, I can simply push that into my queue dot push it, right? Okay. So this is how you would. So if you run this, you would just get the topos of the whole graph, right? Okay. Now tell me one thing: when is the answer possible? If I've been able to topologically sort all the nodes, that means there was no cycle, and I could simply put them in the right order. So then the point is, if my topo dot size is not equal to n, what does that mean? I've not been able to do it, and there exists no such order. So I'll just see out it goes. Angle. And if I'm able to do that, then what will I do? Else, I'll simply output all the elements of loop. So let's see out x. Once I'm done with this, yeah. So I hope this code works. Uh, yeah. So this should work. Let me just try running this once. Okay, there are quite a few compilation errors. Okay, one is for vector, one is for IOStream. I didn't change it to bits. I'm so sorry. So sorry for this. But there are other errors. I think graph is not defined. I think that is because of the vector issue only. Let's run this again, and maybe there are very small errors. This is int u is equal to q dot front. This is wrong. Okay, okay, sorry. It's a very small error. Front is written this way. It's a syntactical error. Okay, now this should be working correctly. So let me just copy this input test case and test if my code is working. So yeah, 34152 is the answer, which matches completely and doesn't to match, but this is the right answer. So that means this works. So this is like, see, if you only want to learn toposort, this much code is sufficient for toposort. This question is nothing but toposort, right? The last part is only specific to the question. That if I'm able to do it, then just print. Otherwise, it was just toposort, nothing else. Okay. Thank you, and if there are any doubts, just put them in the comments. Thank you.